You hold a small device in your hand. It connects you to almost anyone, anywhere. It brings you news, music, and movies. How does this magic happen? It happens through mobile networks. We often hear terms like 2G, 3G, 4G, or 5G. What does that G mean? It is quite simple, really. The G stands for generation. Each number represents a new big step, a new chapter in how we connect. Think of it like updated versions of your favorite space exploration software. Each new version is more powerful. It allows us to see further and understand more. These mobile generations do the same for communication. Before our current focus on 2G to 5G, there was 1G. This was the very first generation of mobile phones. It was all analog. This meant it could only carry voice calls. Like the earliest rockets, 1G was a bold first step, but limited. Then came the digital revolution, and with it, 2G. This shift from analog to digital was like moving from viewing the stars with just our eyes to using a basic telescope. Suddenly things became clearer. This essay will take you on a journey. We will explore these amazing generations, 2G, 3G, 4G, and the current marvel, 5G. We will see how each one changed our world. These generations of mobile technology have profoundly reshaped our lives. They have changed how we interact with each other and with information. Imagine a time not so long ago when making a phone call from outside your home was a rare thing, or when accessing the internet meant sitting at a desk tethered by a cable. These networks untethered us. They put the power of connection into our pockets. From simple voice calls to streaming entire universes of content, it is a story of constant human innovation. A story of reaching for more, for faster, for better ways to share our thoughts and experiences across distances. In the sections that follow, we will embark on a voyage. We will explore each generation in a simple, clear way. We will look at how 2G brought us digital calls and text messages. We will see how 3G opened the door to the mobile internet. Then, we will witness how 4G made that internet fast and powerful. Finally, we will gaze upon 5G, a technology that promises to connect not just people, but everything. We will examine their inner workings, their speeds, and the amazing new abilities they unlocked for humanity. So prepare for a journey through the recent history of connection, a cosmic story of innovation. The second generation of mobile networks, or 2G, was a true game changer. It marked a pivotal shift from the analog world of 1G to the new digital realm. This happened in the early 1990s. Think of it like this. 1G was like listening to music on an old vinyl record, sometimes with scratches and fuzz. 2G was like upgrading to a crystal-clear compact disc. Digital signals are much cleaner and more efficient than analog ones. This meant that mobile phone calls became clearer, there was less static and fewer calls were suddenly dropped. This was a huge improvement for everyone using mobile phones at the time. So how did 2G achieve this digital magic? It worked by converting your voice into a stream of ones and zeros digital code. These digital signals could carry more information more reliably. They were also more secure than analog signals, making it harder for others to listen in on conversations. This digital foundation also allowed for more than just voice. It opened the door for small amounts of data to be sent and received. Two main technologies powered 2G networks, GSM, which stood for Global System for Mobile Communications, and CDMA, which meant Code Division Multiple Access. These were like different digital languages that phones and networks used to talk to each other. The architecture of a 2G network had several key components. You had the mobile phone itself, of course. Then there were the base transceiver stations, those tall towers you often see. These stations sent and received radio signals to and from your phone. Many base stations were connected to a base station controller. This controller managed a group of towers. Then, these controllers connected to a mobile switching center. The mobile switching center was like the brain of the network. It routed calls to the right person and connected to the regular landline phone network. It was an intricate system, designed to make mobile calling reliable. Beyond clearer calls, 2G networks quietly introduced the world to very basic mobile data services. This wasn't the internet as we know it today, not by a long shot. The speeds were incredibly slow. But it was the very beginning of the idea that a phone could do more than just make calls. It laid the groundwork for services like SMS, short message service, or text messages. This simple ability to send short written messages would soon explode in popularity. 2G, therefore, was not just an improvement, it was a fundamental shift. It built the launchpad for the mobile data universe we now inhabit. The most celebrated feature of 2G technology was undoubtedly the improvement in voice call quality. Digital transmission meant calls were clearer, with significantly less background noise and interference compared to their 1G predecessors. This made conversations more pleasant and reliable. But 2G brought another star to the show, SMS, or text messaging. For the first time, people could send short, typed messages directly from one mobile phone to another. This was revolutionary. It offered a quick, quiet, and often cheaper way to communicate. Texting quickly became a cultural phenomenon, especially among younger users, creating a whole new way of interacting. When it came to main uses, 2G phones were primarily for voice calls and texting. The focus was still very much on person-to-person communication. Business people relied on them to stay in touch while away from the office. Families used them for quick check-ins. The cost of mobile phones and services also started to come down during the 2G era, making them accessible to a much wider audience. Some 2G phones also offered very simple applications, like basic calculators, alarm clocks, and even iconic early mobile games like Snake. These were humble beginnings for the app ecosystems we see today. Let's talk about speed, or rather, the lack of it in early 2G. Data speeds on basic 2G networks were measured in kilobits per second or kbps. We are talking about speeds around 9.6 kbps to 14.4 kbps. To put that in perspective, downloading a single small song would take a very, very long time. However, later advancements in 2G technology, often called 2.5G, GPRS, General Packet Radio Service, and 2.75G, EDGE, Enhanced Data Rates for GSM Evolution, offered slightly better speeds. GPRS could reach up to 114 kbps and EDGE could theoretically go up to 384 kbps. These paved the way for basic mobile web browsing and picture messaging, MMS. The main protocols were GSM, CDMA, and TDMA, Time Division Multiple Access. The overall impact of 2G was immense. It truly democratized mobile communication. Phones became smaller, batteries lasted longer, and the digital nature of the network allowed for greater capacity, meaning more people could use the network at the same time. It was 2G that cemented the mobile phone as an essential personal item rather than a luxury. It also subtly began to train us to expect more from our phones than just voice. The introduction of text messaging and very rudimentary data services planted the seeds for the mobile data explosion that subsequent generations would unleash upon the cosmos of information. After the digital clarity of 2G, the world was ready for something more. The third generation of mobile networks, or 3G, arrived with a grand promise to bring a richer internet experience directly to your mobile phone. This was the early 2000s. While 2G had introduced tiny trickles of data, 3G aimed to open the floodgates, relatively speaking. The dream was to access websites, send emails with attachments, and even make video calls, all while on the move. This was a significant ambition. It required entirely new technologies and a more robust network infrastructure. The universe of mobile communication was about to expand once more. How did 3G networks deliver on this promise of increased speed and capability? They used new, more efficient radio technologies, standards like WCDMA, Wideband Code Division Multiple Access, which was part of UMTS, Universal Mobile Telecommunications System, and CDMA 2000 became prominent. These technologies were designed from the ground up to handle much larger amounts of data compared to 2G systems. Think of it as building wider highways with more lanes for data traffic to flow. This allowed for a more consistent and faster connection to the internet, making new mobile services possible. The airwaves themselves were being used in smarter ways. The architecture of 3G networks evolved from their 2G predecessors. While they still use cell towers, often called Node B in UMTS systems, and switching centers, new elements were added to manage the increased data traffic. A key component was the Radio Network Controller, RNC. The RNC managed multiple Node Bs, controlling radio resources and some mobility functions. The core network was also upgraded. It needed to handle not just circuit-switched voice calls like 2G, but also packet-switched data for internet access. This meant the brain of the network became more sophisticated, capable of juggling different types of traffic efficiently. One of the subtle but important shifts that 3G enabled was the concept of always-on data. With 2G data services like GPRS, your connection was often intermittent. With 3G, the aim was to have your device persistently connected to the internet, much like a broadband connection at home. This was crucial for the development of applications that needed to send and receive information in the background, like email notifications or instant messaging. This always-on capability was a fundamental stepping stone towards the app-centric smartphone experience that would truly blossom with the arrival of even faster networks. 3G laid the essential groundwork. Section 5: 3G's capabilities. A world of mobile internet. The star feature of 3G technology was undoubtedly its significantly faster internet access compared to 2G. This boost in speed opened up a whole new universe of possibilities on mobile devices. One of the most talked about new services was mobile video calling. For the first time, you could see the person you were talking to on your phone screen, a truly futuristic concept for many at the time. Mobile web browsing also became much more practical. Websites that were once painfully slow to load on 2G became reasonably accessible on 3G, encouraging businesses to create mobile-friendly versions of their sites. The internet was truly breaking free from desktop computers. With these enhanced capabilities, the main use cases for mobile phones began to diversify rapidly. People started using their 3G-enabled phones for far more than just calls and basic texts. Sending and receiving emails with attachments became commonplace. Downloading music tracks and short video clips turned into a popular pastime. Location-based services like early mapping and navigation apps began to emerge, guiding users through unfamiliar streets. Furthermore, the nascent stages of app stores started to appear during the 3G era, offering a glimpse into the world of downloadable applications that would soon transform our phones into versatile tools for every aspect of life. When we talk about 3G speeds, we see a considerable jump from the kilobits per second of 2G. Initial 3G standards offered speeds typically starting around 384 kbps. However, as 3G technology evolved with enhancements like HSPA, or high-speed packet access, and HSPA+, these speeds increased significantly. HSPA could deliver speeds of several megabits per second, sometimes even tens of megabits per second under ideal conditions. This was a dramatic improvement, making activities like streaming standard definition video feasible. The primary protocols behind 3G were UMTS, which often utilized WCDMA for its air interface, and CDMA 2000, another major 3G standard family. The impact of 3G on society and technology was profound. It truly ignited the mobile internet revolution. Smartphones, which were just beginning to appear, became vastly more useful and desirable thanks to 3G connectivity. It fundamentally changed how we accessed information, entertained ourselves on the go, and even conducted business. The idea of a mobile lifestyle where work, communication, and entertainment were seamlessly integrated into our portable devices began to take firm shape during the 3G era. It was the gateway to a more connected, more informed, and more mobile-centric world, setting the stage for even greater advancements. Section 6, the need for speed, introducing 4G LTE. As 3G networks brought the internet to our pockets, our appetite for mobile data grew. We wanted faster downloads, smoother videos, and more responsive online games. This increasing demand set the stage for the fourth generation of mobile technology, 4G. The primary goal of 4G was simple but ambitious: to provide ultra-fast mobile broadband internet access. It aimed to deliver an experience comparable to, or even exceeding, what many people had with their wired home broadband connections. This was a monumental leap, designed to handle the explosion in mobile data consumption driven by smartphones and a universe of new applications. So, how did 4G achieve these incredible speeds? It relied on a new set of advanced radio technologies. One of the most important was OFDMA, or Orthogonal Frequency Division Multiple Access, which is used in LTE, the dominant 4G technology. OFDMA is very efficient at sending large amounts of data, especially in challenging urban environments. Another key technology was MIMO, or Multiple Input, Multiple Output. MIMO systems use multiple antennas at both the transmitter, like a cell tower, and the receiver, such as your phone, to send and receive more data simultaneously, dramatically increasing throughput and signal reliability. It was a significant redesign of how radio waves carry information. The architecture of 4G networks represented a major evolution. A key characteristic was its all-IP, or Internet Protocol, flat architecture. This meant that all services, including voice calls, could be treated as data packets traveling over the IP network. This simplified the network design and made it more efficient. Voice calls on 4G are often handled by VoLTE, or Voice over LTE, which provides higher quality audio than older circuit-switched voice calls. The flat architecture meant fewer network nodes for data to pass through, which helped to reduce latency or delay. The core network component in 4G is known as the Evolved Packet Core, or EPC. LTE, which stands for Long-Term Evolution, quickly became the global standard for 4G. Interestingly, the very first versions of LTE didn't strictly meet the original international technical requirements to be officially called 4G. However, they offered such a significant improvement over 3G that they were widely marketed as 4G. Later advancements, such as LTE Advanced and LTE Advanced Pro, did meet and even exceed those initial 4G specifications, delivering even higher speeds and better performance. This ongoing process of improvement and evolution is a hallmark of mobile network development, always pushing the boundaries of what's possible. Section 7 4G Power Streaming, Gaming and Beyond. The arrival of 4G LTE networks unlocked a new dimension of mobile experiences, primarily driven by its remarkable speed and lower latency. High-definition video streaming, which often stuttered or buffered endlessly on 3G, became smooth and enjoyable on 4G. This meant watching movies and TV shows from services like Netflix or YouTube on your phone or tablet became a mainstream activity. Online gaming on mobile devices also transformed. Complex multiplayer games that required fast, responsive connections became truly playable, opening up a vast new market for mobile entertainment. Even video conferencing for work or catching up with family became clearer and more reliable than ever before. These enhanced capabilities led to an explosion in how we used our mobile devices. Streaming services saw their mobile viewership skyrocket. Social media platforms became richer and more engaging, with users sharing high-resolution photos and videos effortlessly. Cloud services for storing files or running applications became much more accessible and practical on the go. Our smartphones, powered by 4G, truly evolved into powerful pocket computers, becoming our primary devices for entertainment, communication, navigation, and information gathering. Work also became more flexible, with 4G enabling robust remote access to corporate networks and collaborative tools. When we discuss the speeds of 4G LTE, we are talking about a significant leap. While initial 4G LTE deployments offered peak download speeds in the tens of megabits per second, the technology quickly evolved. With LTE Advanced and LTE Advanced Pro, theoretical peak download speeds could reach hundreds of megabits per second, and in some cases even approach or exceed 1 gigabit per second under optimal conditions. This is a universe away from the speeds offered by 3G. The main protocol underpinning 4G is LTE, which itself is built upon the Internet Protocol. Voice over LTE or VoLTE became a standard feature, offering superior call quality and faster call setup times compared to older 2G and 3G voice. The impact of 4G technology on our daily lives and the global economy has been transformative. It turned our smartphones into indispensable hubs for nearly every aspect of modern life. The app economy boomed as developers created innovative applications that leveraged 4G's speed and responsiveness. Entirely new industries, from ride-sharing services to mobile food delivery, were built upon the foundation of ubiquitous, fast mobile internet. 4G didn't just connect us, it deeply integrated the digital world into our physical experiences, making the mobile internet an undeniable and central force in the 21st century. It wove a new layer into the fabric of our society. Section 8. The future is now exploring 5G technology. And now, we arrive at 5G, the fifth generation of mobile network technology. This is not just another incremental upgrade in speed for your smartphone. While it certainly offers that, 5G is designed with a much broader vision. It aims to be the underlying fabric for a truly connected world, powering not only faster phones but also a vast ecosystem of interconnected devices. Think of smart cities with intelligent traffic systems, self-driving cars communicating with each other and their surroundings, advanced remote healthcare, and highly automated factories. 5G is engineered for this complex, data-rich future, a future where billions of devices are seamlessly connected. How does 5G achieve these ambitious goals? It employs a range of cutting-edge technologies. Firstly, it can utilize higher frequency radio waves, specifically millimeter waves, or MM wave. These higher frequencies can carry enormous amounts of data, enabling super-fast speeds. However, M waves don't travel as far and struggle with obstacles, so 5G also uses mid-band and low-band frequencies for wider coverage. Technologies like massive MIMO or multiple input, multiple output use base stations with a very large number of antennas to send and receive signals much more efficiently. Beamforming allows these antennas to direct radio signals specifically towards individual devices, improving signal strength and reducing interference. Crucially, 5G is designed for ultra-low latency, meaning minimal delay in data transmission. The architecture of 5G is also a significant step forward. It is designed to be highly flexible, scalable, and software-defined. A key innovation is network slicing. This allows mobile operators to partition their physical network infrastructure into multiple virtual networks. Each slice can be customized with specific characteristics. For example, one slice could offer extremely high bandwidth for enhanced mobile broadband, while another could provide ultra-reliable, low-latency communication for critical industrial applications, and yet another could support a massive number of low-power IoT devices. 5G can be deployed with a new standalone 5G core network, or in a non-standalone mode that initially leverages the existing 4G Evolved Packet Core, or EPC. The key features of 5G are often summarized by three main use cases. First, enhanced mobile broadband, or EMBB, which means significantly faster data speeds, multi-gigabit per second, and greater capacity for smartphones, tablets, and mobile hotspots. Second, massive machine-type communication, or MMTC, enabling connectivity for a huge number of low-power, low-data rate devices like sensors and smart meters in the Internet of Things, or IoT. Third, ultra-reliable low-latency communication, or URLLC, providing extremely dependable and near-instantaneous responsiveness for critical applications such as remote surgery, autonomous vehicle control, and industrial automation. 5G is more than just a faster network. It's a versatile platform for innovation across countless industries. Section 9, From Voice to Vast Data, the journey from 2G to 5G and beyond. Our journey through the generations of mobile networks has been quite a voyage. We began with 2G, which transformed mobile communication by introducing digital voice calls. This brought clarity and security. It also gifted us with the simple magic of SMS text messaging. Then came 3G, which bravely ventured into the realm of mobile data. It opened the doors to the mobile internet, allowing us to browse websites and use early apps on the go. Following this, 4G burst onto the scene. It delivered the high-speed mobile broadband experience we craved, making video streaming, online gaming, and a universe of rich applications a daily reality. Each generation built upon the successes of its predecessor. Comparing these Gs reveals a dramatic and accelerating evolution. Speeds have skyrocketed from the mere kilobits per second of 2G to the megabits per second offered by 3G, and then greatly expanded by 4G, and now to the multi-gigabit per second potential of 5G. Latency, which is the delay in data transmission, has also plummeted, from noticeable delays in earlier generations to the near-instantaneous response promised by 5G. The primary focus also shifted. 2G was fundamentally about voice, 3G introduced functional mobile data, 4G was all about providing a robust mobile broadband experience, and 5G aims higher still, seeking to seamlessly connect everything, everywhere with tailored performance for a vast array of applications. This incredible evolution is far from over. Even as 5G networks continue to be deployed and enhanced worldwide, researchers and engineers are already looking towards the horizon, envisioning what 6G might bring in the next decade. Each new generation seeks to overcome the limitations of the previous one. It aims to meet new societal needs and unlock possibilities that we can currently only dream about. Perhaps 6G will integrate terrestrial networks with satellite systems more seamlessly, or use even higher frequencies, or incorporate artificial intelligence more deeply into network management. The quest for better, faster, and more ubiquitous connection is a fundamental human drive, constantly pushing the boundaries of innovation. The impact of this journey, from the first digital calls of 2G to the interconnected vision of 5G, has been nothing short of revolutionary. These mobile networks have fundamentally reshaped our societies. They have altered how we learn, how we conduct business, how we entertain ourselves, and, most importantly, how we connect with one another across the globe. From a simple voice conversation spanning a few miles to a complex, global web of interconnected people and machines, the evolution of mobile networks is a testament to human ingenuity. The cosmos of communication continues to expand, and we are all part of this grand, ongoing adventure.